Okay, so we're going to talk about graphing cosine functions now, which if you've done the sine function already, it's super fast, super easy, because most of the things that we learned with the sine graphs are the same for the cosine graphs. Cosine curves are also periodic, and it has the exact same period that a sine function does. So the period of our cosine function is going to be 2 pi. So you can fill that into your little box there. The period's going to be 2 pi. The parent function of a cosine curve, we get the exact same way that we did a sine curve. So we're really looking at the quadrantals of the unit circle. So the 1, 0, 0, 1 at 90, negative 1, 0 at 180, 0, negative 1 at 270. Because the period is 2 pi, we're going to graph these the exact same way. So on both the left and the right of the x-axis, you need to get up to 2 pi, and I always break it down into 4 pieces. So on the left side, we go to negative 2 pi, negative pi, and you only need to label 2 of the 4. So if you, all right, so you've got at least 2 labeled on both sides. Just like with the sine function, your y-axis is going to go up to positive 1 and down to negative 1. So just like on the sine function, your domain is going to be all real numbers because it's periodic. It's going to continue the curve over and over again. The range is also the same. Your y is going to be between positive 1 and negative 1. As you can guess by the way that I labeled the y-axis, the amplitude of your cosine function is also 1 because, again, remember that amplitude represents the distance from the middle of the graph, which we call the midline, to the top of the hill or the midline to the bottom of the valley. So our max value is going to be 1 and our min value is going to be negative 1. Now, where they occur is the part that's going to be different than it was on the sine curve. So if we use our unit circle here and we are graphing it at 0, because remember that the cosine value is the x value. So if I'm looking at the x values to graph them, at 0 the cosine value is 1, whereas with sine it was 0. So at 0 my starting point is actually the hill. It starts at the hill instead of the midline. So 0, 1 we plot. Then at pi over 2, the value is 0. So it's down on the axis at that first notch mark, which is pi over 2. At pi, it's down to negative 1, so we go down. That's the bottom of the valley. At 270, it's back up to 0 at the midline. And at 2 pi, it's back up to 1. So the curve is the same type of curve. Essentially, we've just shifted it over because we're starting at the hill instead of at the midline. So if we continue the pattern on the negative side, after it goes up to the valley, it comes back to the midline. So at negative pi over 2, it's at 0. Then at negative pi, it's going to be down at the bottom of the valley at negative 1. At negative 3 pi over 2, it's at 0, and at negative 2 pi, it'll be back up at positive 1. So when you connect it, it has the same shape, just different starting points. And if you forget which one is which, you can always look at the unit circle real quick and just look at that 0 value. After you've done them a couple times, I think most of you will know that the cosine is the one that starts out high. It starts at the max value rather than starting at the midline of 0. So our max value here occurs for the first time at 0, and then because of the period, that max value occurs again every 2 pi. And so we express that the same way we did with the sine. We do plus 2 pi n, where n is any number. And this time I'm going to simplify it because 0 plus 2 pi n is just 2 pi n. The minimum value occurs for the first time at pi. So if you look at the first valley on the positive side, and then again plus 2 pi n because it repeats every period cycle. So the learning goals are the same as they were for sine. We need to be able to identify the period and the amplitude. We need to be able to write the equations when we're looking at the graph, and we need to be able to graph them ourselves by hand. So same thing as with, the only thing that's changed for the standard equation is the fact that it's cosine rather than sine. Everything else still stays the exact same. Amplitude is still A, the period is still 2 pi divided by B. So if we're looking at example 1, state the amplitude in the period and then graph the function. So if we look at y equals 2 cosine x, the amplitude is the A value, which is the number in front, which is 2. So amplitude is 2. Then my B value, 2 pi over B equals, the period is 2 pi. So in this case, my B value, the number in front here, you can see is just 1. There's nothing there. So B is 1, which is how we get 2 pi to equal itself. So when we graph it, same thing as the sine curve. On the x-axis, do the same thing I did on the parent graph because this has the same period as the parent graph. So go to 2 pi and negative 2 pi, label your pi's, and then make the halfway points as well, which you do not need to label. This time on the y-axis, because this function has an amplitude of 2, that should be your high value is 2 and your low value should be negative 2. And then we're just going to do the exact same thing that we did with the parent graph. So this one starts high, and on the parent graph it starts at 1, but here, since we've changed our amplitude, we're changing the height. Now we're going up to 2, but it's the same mark, it just happens to have a different label. Because our period's the same, this is going to work the exact same. So I start high, then I go back to the midline, then low to the minimum, then back to the midline, and then back up, because when you get to 2 pi, you should have completed an entire cycle. So it should be back up to the maximum at 2 pi. On the other side, again, we're just following the pattern. So I was at the maximum, so go back to the midline. Then at negative pi, should go down to the minimum. Then back up to the midline, and then finally back up to the max. So then connect your points in a pretty curvy fashion. And we've already got our amplitude is 2, our period is 2 pi, so we are done. All right, so now let's look at B, and this one's going to be a little more difficult because our B value is 4 rather than 1. So the A doesn't matter if it's a fraction, that doesn't trip us up on these because it just means that we're going to relabel our point as 2/3 instead of 1. So A is 2/3, B is 4, so my period is going to be 2 pi divided by 4. So when I take 2 pi divided by 4 and I reduce it, that gives me pi over 2. So my period here is pi over 2 instead of 2 pi. Again, the way that you graph it, the graph itself is always going to have the same shape, at least in this section, until we start shifting them. The only thing that's going to change on your graphs are the labels. So here we're going, our last mark should be at pi over 2, which means our medium, the middle mark, should be half of that, which is pi over 4. And then we put our other 2 that we don't need to label. On the left side, lowest x value is negative pi over 2, so also label negative pi over 4. And your ones in between. So again, amplitude was 2/3, so the high value is 2/3, the low value is negative 2/3. And again, the graph is going to look exactly the same. The only thing that we're changing is the labels. So I'm going to draw it exactly the same way that I did in A and exactly the same way that I did in the parent function. So the shape is going to be the exact same. I start high, I go to the midline, I go to the valley, back to the midline, and then back up to the hill. On the other side, same thing, to the midline, valley, midline, hill, and then connect them. So again, if you're just looking at my blue curve versus my red curve, they look the exact same. The only difference is my labels, because that's the amplitude and the period. All right, so last thing that we need to do is to be able to write the equation of the cosine function when they give us the amplitude and give us the period. So the amplitude's the easy part. That means that my A is 1/2. If the period is 2 pi, then that means that my B value, because 2 pi over B equals the period, that means my B value has to be 1, because the period has not changed from the parent graph. So that means that B is 1. A we said was 1/2, so we're just plugging that in into y equals A cosine BX. So we plug in the 1/2 for the A. B is 1, so we don't need to write 1x, just write x. So 1/2 cosine x should be our value there. All right, last one. So amplitude is 4, so A is 4. It says the period is 3 pi over 5. So this one you're probably going to have to write out. Do 2 pi over B equals 3 pi over 5, because 2 pi over B is equal to our period. Just like yesterday, I said that when they're both fractions, it's probably easier to solve this as a proportion. So cross multiply 2 pi times the 5 to get 10 pi, and then B times 3 pi on the other side. So in order to get B alone, then we need to divide both sides by 3 pi. So the pi's cancel each other because we've got one on top and one on bottom, but then 10/3 does not reduce. That's as far as we can go with that. So we've got an A value of 4, a B value of 10/3, so now we just need to plug it in. So y equals 4 cosine, and when we plug the 10/3 in, the x always goes in the numerator, so it's 10x over 3. All right, short and sweet video. Hope you have a swagtastic day. Fourth period would like to say bye to you.
Bye.